Now we are moving to the next, that is C is basically your addition of Grignard reagent. Addition of Grignard reagent. And you have studied this in previous chapter. I will go on. So basically, what is how we are going to add this Grignard reagent in an aldehyde or ketone? So I'm going to give you a question like this: CH3CHO, adding of RMGBr. Let's say this is your RMGBr. Can you do this reaction? And after whatever you got in this place will be hydrolyzed in the next step. Can you do this reaction? Yes or no? Because you have already studied this. If you are not able to solve or think anything about this question, just let me know. I will do it.
Okay, just show this up.
Yeah, I will solve it.
Sir, is it CH3CMGBr plus OH?
Okay, just match the answer. See, how I'm going to write this? This you can see. Can I write this CH3 and then C double bond O and then H? Now you can see this is R, that means alkyl group, which will have negative sign because it is more reactive than magnesium. So I'm going to put delta positive here and delta negative here. In the same way, oxygen is very electron negative as compared to carbon. So delta negative, and here it will be delta positive. Now what you need to do is just opposite charges attract each other. So this R will attack this, and you can see oxygen will withdraw electron from carbon. So oxygen will have negative sign, and you can see this this carbon will have positive sign because oxygen just took electron from carbon. So this alkyl group will attack this carbon, and this is positive, so this will go with oxygen. So what is the product A? I'm going to write it CH3 first, and you can see then there is O negative, and MgBr will go to O. Now you can see this C has already H, and this R will go to this. So can I write this in a more ordered way like this: CH and then R? O minus Mg plus Br. So this is, we can call it adduct or intermediate. We can call it intermediate. So now you can see, am I audible to all of you?
Yes.
Yes.
Anushka? Okay, thank you. So this is your intermediate and what we call adduct. We also
So
call
can you just share this?
The screen is not visible.
Okay. Okay, it will be visible now. Just let me know when you are able to see the screen.
Yes, sir.
Yes, sir.
Everyone can see the screen? Okay. So this is your adduct, or we also call it intermediate. Now, after this formation of adduct or intermediate, you are going to hydrolysis. Hydrolysis, that means reaction with water, and we know this water has two parts, H plus and OH minus. H plus and OH minus. Now again, what you need to do, it's very easy. Positive will go to negative and negative will go to positive. So you will get a product like this, CH3CH and OH will be there. with O negative, H plus will go, and there was R, and there is byproduct that will be Mg, and then OH will go in between Mg, and this is your byproduct, and this is your main. So what you just need to do, it's very simple to understand. Oxygen is more electronegative element, so oxygen will take electron from carbon, so oxygen will have negative sign. Now there will be deficiency of electron on carbon. Now come to the next reactant, that is Grignard reagent RMgBr. So what you need to do is just look at the alkyl group, which is carbon containing chain, and this is Mg, which is magnesium metal. Metal are electropositive element, they can easily donate electron, and this carbon is very more electronegative than magnesium. So this R will take electron from magnesium, and it will attack on the carbon which has less electron. So this bond will break, and it will go like this, and this magnesium plus will go to oxygen because it has more electron or negative charge. So you can get the adduct, and then again there was O negative Mg plus. So when you are going to do hydrolysis, water has two parts, H plus and OH minus. H plus will go to O negative and then break this, and then OH minus will go to Mg. Is that clear, everyone?
Yes, sir.
Okay, please do it. Then I'm going to give a question on this. Then we will talk about ketone also. Let me know when you are done with this. How many chapters you have completed, or you can tell me how many chapters left for the final annual exams, or just for general knowledge I'm asking in this batch.
Sir, in our school, we are left with chemical kinetics.
In this class, for this batch, I am talking about Anushka.
Oh, sir, we are done with haloalkenes, haloarenes. Then we did this. We were doing this
Alcohol.
chapter, and then
You
apart
completed alcohol.
electrochemistry as well.
Okay. So, just wait a minute. Please do it and let me know when you are done. Everyone done with this?
Yes,
Sir,
sir.
almost.
Okay, I'm just gonna slide it little down and I will give you a question. Just do it. CH3, CH2, CHO. And then reacting with, at the place of R, I'm going to take CH3, MgBr, and you will get an adduct A. After this, you are going to do hydrolysis, and let me know the main product, that is B, and C is your byproduct. So please do it. Do let me know if you have any doubt. Anushka, you are in this batch from starting, right?
Yes, sir.
Okay, I'm gonna ask some questions. Just let me know. You are
Yes,
done
sir.
with. Have you completed alcohols, phenols, and ethers?
Yes, sir.
Okay. After that, this aldehyde. Have you completed amines?
No, sir, we didn't do that. Only the first and second
Okay.
chapter we did. Haloalkenes and the alcohol, phenols, and ethers.
Alcohols. Okay. Biomolecules didn't do. Polymers also not, right?
No,
So
ma'am.
in this second book, we have 3 chapters. You have 3 chapters. Now, in the first book, come to the first book. Have you completed solution?
No, sir. In the first book, we only did electrochemistry.
Only electrochemistry is done, and all other chapters are there, right?
Yes, sir.
Okay. Thank you. Please do this. Thank you so much.
Till when we will finish the portion?
Which portion? All the syllabus or this chapter?
Yeah, so full syllabus.
Okay, that's what I was asking about. I will just review this with management and I will let them know, and you also. Okay, I'll see how many chapters are there to be completed. The target was basically till 15th December, but if you are going to look at the chapters that we are left with, like in the first book, we have solution, which is a quite big chapter, but we can do. And after that, chemical kinetics, not that much big. Surface chemistry, and the main important chapter that is also big is P block, coordination compound, D and F block. So I will talk to them and we'll see. We'll try to finish this syllabus as soon as possible, but
Sir, I guess surface chemistry and P block is deleted.
all the chapters or some of its topic. I think solid state is deleted.
So
Anushka?
solid state, surface chemistry, and P block elements are deleted.
All these 3 chapters are deleted.
Yes,
Yes,
sir. Surface chemistry, P blocks, and solid state from the first chapter, and polymers from the second book.
yes, sir.
Okay,
Yeah,
that means we have 2 chapters, main chapters in organic chemistry left. That is amines and biomolecules, right?
Sir, yes.
And then in this first book, this solution, and then come to the chemical kinetics, and then come to the metallurgy. What do you
No,
think?
sir. We don't have that. We
Metallurgy.
just have solution, chemical kinetics, D and F block, and coordination compound.
Okay, D and F block, and then coordination compound. Okay.
4 chapters from the first book and 2 chapters from the second book.
I'll look into it. All of you will be. What I want to say is that your contribution is very important to complete this syllabus. As soon as you understand it or practice questions, it will be very easy. So everyone done with this question? This question. Have anyone got the answer, right answer, or answer, any answer? Or should I explain?
Sir, A is CH3, CH2, CH, OMGBr, CH3.
And where is CH3? Here it is. Like
Yes,
this.
sir.
And then after H2, what you got as main product? You can
CH3,
name that.
CH2, CH, OH, CH3.
CH3, CH2, CH, OH, CH3. And the byproduct is basically your MgOH.
MgOHBr.
Very good. Anyone got this? Can you name this? This is the name of this product. 1, 2, 3, 4. Butane 2-1, right?
Yes.
Anushka, have you got the answer? Ahmad.
Sir, how did we? Sir, I got till that. After for C, how did we get that? B plus C, how we?
Oh, see, you got this, right?
Yes, sir. That I got.
So you can see this is O will have negative and this will have positive charge. Yes or no?
Yes.
Now you can see this is H2 has two parts, that is H plus and OH minus. What do you think? H plus where it will go? It will go to this oxygen. So
Yes.
what we will have now CH3, CH2, and then CH, and then OH. With O, there will be H. That will be coming from this H2O, and this was CH3 downward. So I'm gonna write it like this, and this negative will go to this Mg. So the C will be, that is basically byproduct, that is not necessary like this.
Okay.
Anushka, do you have any doubt in this?
No, sir. Understood.
Okay, thank you. So I'm gonna give another question. Alan. Okay, I'm gonna give another question. That is basically CH3 C double bond O. The concept will be same, the mechanism will be same. Please do this. Same as the previous one. You can see this is ketone, but the mechanism will follow same order or same as compared to this aldehyde. So you can do this easily. I think you can do this. Please do it. If anyone have any doubt, please ask me.
So CH3COMgBr CH3H.
Zed, have you got this? CH3CO minus Mg plus Br. And then you got CH3 and then again CH3. Have you got this?
No, sir, I got H on the right side of C.
That's wrong. You know what? It's very...
Is this the final answer?
No, it's not the final answer. The final answer, the main product will be CH3, COH, and then CH3, and then CH3. This is the final answer. I know what you have mistaken is like in the previous question, there was H, that is this. But here you have CH3. So instead of placing H, you should write CH3. See how it happened. You can see oxygen is more electronegative, so it will attract carbon's electron. So there will be delta negative charge. And since carbon is donating its electron, so it will have positive charge. Now again, you can see this is metal, so positive. This is non-metal, so negative. So negative will go to positive and positive will go to negative. Now what will happen? You can see O minus Mg plus Br, and you can see there was CH3 on the right hand side, there was CH3 on the left hand side, and this CH3 is coming on the bottom. Are you getting my point? Zad, Anushka,
Yes,
Ahmad,
yes.
Alan. And again, if you are going to pass it through or hydrolyze it, you have two quantity. You have two parts in this water. That is OH, H plus and OH minus. So this H plus will be going with oxygen. So you are forming an alcohol, and the next negative part is basically going with Mg. This is the byproduct. Anushka and Ahmad.
Yes, sir. Understood.
Okay. Please do let me know when to slide down. I'm going to give the last question on this and then we will move to the next type of reaction. We have studied this reaction basically in preparation of alcohols from carbonyl compounds. That is from aldehyde and ketone. Please do let me know when you are done with this.
Done, sir. Understood.
Done with the question also.
Question I'm doing, sir. The above explanation understood and done that question.
Thank you, Anand. Alan, why are you not responding? Is your mic not working? So I will suggest all of you to be serious about your board exams because only 2 to 3 months left, and try to start solving the sample papers. And if you have got any doubts, whether it is concept or any question, just ping me on WhatsApp or Learnivio's WhatsApp. They will fix a meeting for us. Either you can join in group or you can join alone.
Sir, is it's CH3, CH2, OMGBr.
Okay, so Zed,
Yes,
whether
sir.
telling me the chemical formula, can you name the final product?
Okay, sir, I'll
Can
try.
you? Yes, just do it. Because if you are going to write the name of the product, IUPAC name, there will be that will be very beneficial for you to make your IUPAC very strong. If you can do the reaction, if you can prepare the product, that is very good. Just name it.
Methyl butol.
What is the position of methyl? Who will say that? How can I understand that where the methyl is?
2-methyl butol.
Your IUPAC is quite weak. I will suggest whenever you are going to your concept is quite clear. Like you can do the reaction, but you know what will be the question in your exams? Write the name of the major product. You can do the question like you can do the whole mechanism. You have solved the product. You got the answer, but you cannot if you are not going to write the correct name of IUPAC, there will be deduction of marks. So please, whenever do, just name it. See what's wrong in your name. 1, 2, 3, 4. So first, always remember that whenever you are going to do IUPAC, first you are gonna write the name of substituent. You are gonna write the name of substituent that we also call it branch. And then we'll come to the parent chain. Parent chain. And then we'll come to the nature of bond. Then we'll come to the nature of bond. Nature of bond, that means single, double, triple. That means N in I. And then we'll come to the functional group. Functional group, that means the name of the functional group. Now you can see if there is no substituent, then we will directly jump on parent chain. Okay, so you can see there is a branch. There is a branch. So at the second position, it's 1 carbon. That means meth. And whenever you are going to use it as a branch, you are going to add YL, so it will be 2-methyl. Then jump to the carbon parent chain, that is 4 carbon, that means but. Now tell me the nature of the bond. Nature of the bond single, so it will be A. And then come to the functional group, and its position is second. And since it is alcohol, so its name will be O. Is that clear, Zad?
Yes, sir.
So your mistake was very little. Like you just told me 2-methyl but, 2-ol. You didn't define the nature of the bond, and maybe that depends upon the teacher or examiner how he's gonna cut your marks. Like if he wants to cut 1 marks, he can do that. Can I change the slide? Ahmad, Anushka,
So
Ali.
just 1 minute. 1 minute, sir.
Okay, no problem.
Done, sir.
Now going to start the next reaction, that is basically addition of alcohols. If you are going to add alcohol to this carbonyl compound, that means basically especially aldehyde and ketones, addition of alcohols. What will be the product? It's very easy to understand. So addition of alcohol to aldehyde takes place in the presence of hydrogen gaseous HCl. So we are going to do this R-OH, and then you can see this is HCl gas. HCl gas. What will be the product? It's very easy to just write the name of the product. There will be OR dash and there will be OH. And this is called, I will explain the mechanism. This is called hemiacetal. This is called hemiacetal. And if you are again going to react this with R-OH in the presence of acid, then you will get RCH and then OR dash, and then here will be, it is also OR dash, and there will be removal of H2. How did this reaction took place? It's very easy. See, the reaction in organic is like whether it is whether there will be some mechanism behind it, or whether it will be you can see name reaction, so you have to see what is going on with the reaction. And the best and easiest way to do is this negative and positive. Just play with negative and positive, just like this. You can see, can I write this RCHO as RC double bond OH, and I'm gonna do the same with R-OH. So can anyone tell me between carbon and double bond oxygen on which there will be negative charge? On oxygen there will be negative charge, and on carbon there will be positive charge. Can anyone tell me on which negative there will be negative charge? There will be positive charge on. Yeah. So now what you need to do is just add this man, and you will get your answer. Now you can see that this is R, then C, and there was H, and then you can see this bond broken, and then there will be OR dash, and then again there will be OH. Is that clear? Now again, if you are going to react this with R-OH, it's very easy to understand. Again, this will be positive, this will be negative. And now you are going to differentiate between this OH. Hydrogen is less electronegative, positive, oxygen is more electronegative, so negative. So this will come to this, and again you can see this is RCH, there was OR dash, and then again OR dash, and then there will be removal of water. This is how reaction took place. So it's very
how
easy
will know that
to
it
write
will react with OH only, not with OR dash?
See what this is. If you are going to do this, basically this is what we call it. Wait a minute. That is a good question. But if you are going to do this, like OR dash. There will be positive and there will be negative, Z. Yes or no?
Yes, sir.
See, what is your what was your answer is that what was your question is that why we did positive with this and negative with this? Why we didn't do with this, right?
Yes, sir. Why did the reaction didn't take place with the OR dash?
Yeah. This was the question. So if you are going to do the same, like this will be positive, this will be negative, and then this will be positive, this will be negative. There will be nothing. Uh, there will be no change basically. I'm gonna just write the first reaction. I'm gonna explain it. There will be no change because R dash will be replaced by R dash. Are you getting my point?
Yes, sir.
Okay, then I will again explain. First, write this reaction, and whatever is your doubt, it's good. It's good. Anushka, have you started solving sample papers? Okay.
Yes, sir. I have.
What about you, Zad, Ahmad, Alan?
Yes, sir. Can you repeat?
Have you started solving sample paper?
No, sir.
Okay. Just let me know when you are done with this.
So just started doing the sample paper.
That's good. And this is called acetyl. Ahmad, very good. Keep it up and just start doing chapter wise. And just after finishing the syllabus, just from basic from one day, day one, after finishing the syllabus, you are going to at least do one separate sample paper of any subject each day, every day. Like if you are going to do, we just finish the syllabus here. Tomorrow you are going to do a sample paper for 3 hours, whether it is physics, chemistry, maths, bio, English, whatever is your subject. Just make sure you are going to solve a sample paper on a daily basis. Everyone done with this?
Yes, sir.
Okay. Coming to your doubt, if you have this RCHO and this OR dash and this is OH, and you are going to react this with R dash OH. So you can see you have told me that this will have negative, this will have positive, this will have positive, this will have negative. So what this will go to this with the and you will get a product like this. Again, the same as the reactant. Are you getting my point, Zed?
Yes, sir.
So write this name is acetal. Its common name. This is hemiacetal. There might be a question.
We'll get
Write the preparation
ROH,
of
right? R dash
hemiacetal.
OH.
Where? Yeah. Again, like it will be same. Like the reactant will be like the product. Are you getting my point?
Yes, sir.
This OH minus will combine with this R dash OH. So basically, whatever is your reactant will be your product. So why you are gonna do that reaction? Are you getting my point?
Yes, sir.
You have already done. Okay. Anushka, should I change the slide? Can I change the slide? Everyone done with this?
Yes, sir. Done.
Okay. So we just did addition of alcohol in only aldehyde. Now we are gonna do this in ketone. So this is your C double bond O and then R. And there will be addition of this glycol, basically 1 comma 2 ethane diol or ethane 1 comma 2 diol. Then see there will be formation of, in the end there will be formation of basically cyclic compound. So this reaction is in the presence of HCl gas and dilute hydrochloric acid. So it's very easy to understand. There will be CO, and there was 2 R, so this will be R. and then there will be CH2, and then there will be CH2, and then you can see this is your cyclic compound, and there will be removal of H2, and this is known as, its common name is ethylene glycol ketone. I think you can understand the reaction on its own. If you don't understand, just let me know. I'll do that for you.
So can you just explain this once again?
Yeah, I just wrote, I didn't explain it. So can I write this as this, Anushka? Can I write this in reverse manner?
Yes, sir.
Okay. And I'm going to write this. And what you need to do in both the cases, have you seen anything common? In the previous question, we just removed water, dehydration took place. Here we are going to do the same. We are going to remove water, and the water will be removed by removed by this, like this. H2O will be removed. Now, in order to satisfy carbon's valency, what carbon will do? You can see there is oxygen. Let me change the color. There is oxygen, there is CH2, there is CH2, and there is also O. So this oxygen will come out like this. When oxygen will be in between two atoms, it will make single bond, never make it double bond, because there will be coordinate. So this is how reaction took place. In both the situations, we have removed water molecule. Please do let me know when you are done with this.
Sir, done.
Very good. Zed, are you done with this?
Yes, sir.
Very
Yes.
good, everyone. Thank you. Now, moving to the next type of chemical reaction. It's very easy. The next is basically addition of ammonia and its derivative. Do you know what is ammonia? See, ammonia, you have seen NH3, and H will be replaced by anything that is known as this, what we call it, ammonia derivatives. Like this is NH3, and everyone knows that this is ammonia. And if I'm going to replace this H, one of the H of ammonia with Z, this will be known as ammonia derivatives. So see how the reaction took place or take place. It's very easy to understand. This is your carbonyl compound, whether it can be aldehyde or ketone. So we are going to react this with H2N. Again, the reaction is very easy. You just need to remove the water. You just need to remove water. So again, what you will have, it's very easy. C, and this bond was free. And then there will be a single bond with OH, and there will be a single bond with terminal. Just don't remove in this place. First, I'm going to write the reactant. There will be like this OH, and then there will be NHZ. And then again, there will be removal of water, C double bond N, Z, and then there will be removal of water. First write it, then I'll explain how this reaction takes place.
What's the reagent in the first reaction?
What reagent is nothing like this. This is ammonia derivatives or ammonia reacting with carbonyl, okay? Or this is a reversible reaction. Also, Z can be alkyl, Ri, alcohol, NH2, C6H5, NH, NHCO, NH. Just let me know when you are done with this so that I will start explaining. It's very easy.
Yes, sir. Done.
Done?
Yes, sir.
Okay.
Yes, sir.
Again, the same thing will be repeated. Yeah, are you done with this? Ahmad, Alan, Ahmad,
Yes, sir.
you can see. Thank you. This is the reactant, and another reactant. I'm going to write it like this. So as you can see, this will take electrons. So this will have negative and this will have positive. And you can also, so nitrogen is more electronegative. So it will have negative and this will have positive. So this and this will come. So again, this double bond will be broken. And with O, there was H. And with this, NHZ comes. And then again, removal of water will take place. And how removal of water will take place? From this H2O and then H. So you can see this is like this and NZ left. Now you can see carbon has only 3 bonds, but carbon should make double bond. Sorry, 4 bonds total. So we are gonna make double bond with carbon and nitrogen, and you got the answer along with the removal of water. Along with the removal of water. Please do write. Do let me know when you are done. Let me know when you are done with this.
Done, sir.
Very good. Now, the next chemical properties of this aldehyde and ketones comes out to be. The next is basically, the first was basically nucleophilic addition reaction. Now the next is reduction. We are gonna reduce this alcohol and also, sorry, we are gonna reduce this aldehyde and also ketones and see what we will get. So in the first place that you have already studied in the previous chapter, that is reduction to alcohols. either of aldehyde or ketones reduction to alcohols. So basically, if you are going to use, this is just suppose if you have this CH3CHO and you are going to use a reducing agent like sodium boron hydride NaBH4 or lithium aluminum hydride LiAlH4, then you will get CH3CH2OH. Now, how did this reaction proceed? It's very easy to, whenever reduction will be there. Can anyone tell me what is reduction? Can anyone tell me what is reduction?
Addition of hydrogen.
Addition of hydrogen. So what you need to do is add hydrogen, and in order to add something in carbon compound, you need to break old bond, because carbon making already 4 bond and it cannot expand its tetravalence. It cannot make 5 bonds more. So you have to break one of the old bond and add hydrogen like this, and you can see that this is CH3. Now this is CHH, that is CH2, and above you can see this OH. So this is how reduction takes place in aldehyde. You can do that easily. Just break one bond, there was double bond. Yeah. Zach.
So how this CH2 came? Can you explain again?
CH2. Okay. Just see, you just told me that what is reduction? Addition of hydrogen, right? So there is bond between a double bond between carbon and oxygen. So in order to add hydrogen, we need to break old bond. Yes or no?
Yes, sir.
So what we do is break the one of the bond between carbon and oxygen. And since we just break one bond between carbon and oxygen, so now we have a valency free carbon. We have one valency free of carbon. So we will add hydrogen to this carbon and also add this hydrogen to oxygen. And you will get carbon already has this hydrogen and we just added another hydrogen. So we have now CH2. CH3 was there and then it becomes CH2 and then OH. Is that clear?
Yes, sir.
Okay. So I'm going to give you another question, and in
Sir,
terms
this
of
hydrogen will be added only near the double bond.
yeah, it will be added near the double bond. Okay. Reduction you are going to do this in double bond. I'm going to give you 2 questions, and just let me know the name of the product. And you are going to use sodium boron hydride, which is a reducing agent. And what reducing agent does? It reduces. Just let me know when you are done with this.
Sir, done.
Are you done with the question? Have you got the answer? Or you have done the above one?
Sir, I did the above one, not the question.
Okay, please do the question.
Yes, sir.
So is first one propane, one all?
Yeah, that's good.
Sorry, second one, propene to all.
Propene.
Yeah.
Have you got double bond?
Yeah, so because its own.
So what? Just use the mechanism that I explained, and it's very easy. What you need to do is just break the bond, one of the bond, add hydrogen. Then what you will get? CH3, CH becoming OH. It is propane to all.
Okay,
Just
okay, okay.
count the bond that carbon forming at middle at middle.
Okay, sir, I didn't
Second of the
counted the hydrogen bond. That's why I did.
Just let me know, Anushka. Have you got the answer?
No, sir. I'm doing.
Okay, no problem.
Sir, could you write the answer for the first one as well?
Yeah.
Propane one all.
Okay, CH3, CH2, CH2, and then OH.
Sir, for the first one, I got it as CH3, CH2, CHOH. I got it like that.
Not wait. If you're going to break it, this is H, this is H. Already hydrogen was there, and this hydrogen makes it CH2, H2, and this is OH. Okay.
Yes.
And if you're going to count the number of bond of this hydrogen, if you got CHOH, you will get only 3 bond, but carbon makes 4 bond.
Sir, can you just explain
Yeah.
how did you get propane to all? Because even I got actually propane to all.
Ahmad, can you count the number of bond of this carbon? How many this carbon making bond? How many bonds?
One,
How many bond it is making with your product, on your product? 5.
yeah. Okay.
Can carbon make 5 bonds? First question. Carbon cannot make 5 bonds. See, this is your reactant and this is your reagent that you are using. This is your reagent that is basically your reducing agent.
Okay.
So you need to break one of the bond and add hydrogen here and hydrogen here. Okay.
Okay.
Oh, there is slightly mistake. Oh, everyone got it. So see, what will happen here? So you will get basically CH3, CH, and then okay, it's okay. OH and then CH3. Yes or no?
Yes.
So now you can see that this carbon making 4 bond, one with hydrogen, one with this, one with this, one with this. So this is how the product becomes propane 2. Okay.
Okay. Okay.
Just let me know if you have any other doubt.
Okay.
Can we move to the next reaction?
Yes, sir.
I'm going to change the slide, and then the next part of reduction is reduction to hydrocarbon. Reduction to hydrocarbon. And there are 2 named reactions. That means basically you are going to use a very strong reducing agent that will directly convert, either it will be ketone or aldehyde, into hydrocarbon, that means alkane. So the first is basically known as Clemenson reduction. Clemenson reduction. Now see what is Clemmensen reduction. So it's very easy. I'm going to write a point about it. Of aldehydes, that means 3 double bond O, or either ketones, that means 3 double bond O, same, is reduced to CH2, is reduced to CH2 group on treatment with zinc amalgam. That means basically Zn Hg. Hg is mercury, zinc amalgam, and concentrated hydrochloric acid, and this reaction is known as Clemmensen reduction. So see how the reaction proceeds. It's very easy to understand. If you have anything like this aldehyde, or it can be ketone, and if you are going to use zinc amalgam in the presence of concentrated HCl, this HCl should be concentrated. So what you will get, you are going to break this both bond between carbon and oxygen, and for one bond you are going to add one hydrogen and hydrogen. For second bond you are going to add one hydrogen and hydrogen. So you can see on the right hand side you just remove H2. H2 will be removed, and now you can see this is like this. This will be H, because this hydrogen will combine with carbon, this hydrogen will combine with carbon. In this way you just converted an aldehyde into alkane, and this is known as Clemmensen reduction.
Sir, how we got 4 hydrogen?
Clemmensen reduction. What is reduction?
Addition of hydrogen.
Addition of hydrogen. So
Sir,
don't think about
but carbon
how many,
already has 2 bonds, right?
Carbon already has 2 bonds. That means carbon is making 4 bonds before, and after reaction carbon making 4 bonds. Let me again explain it. In the previous question, if we had broken one of the bond between carbon and oxygen, we added 2 hydrogen, and in this we just broke the 2 bond. That means we need for this bond we added 2 hydrogen, for this bond we added 2 more hydrogen. So on the left hand side, whatever is the hydrogen will combine with this carbon, and this hydrogen on the right hand side will combine with oxygen. Is that clear?
Yes, sir.
Okay, so if I'm going to give you a question like this, just let me know the IUPAC name of the product. Zinc amalgam, and then concentrated HCl. Let me know the name of the product.
Sir, oxygen make 2 bonds, right?
Yeah.
Sir, is it propanol plus water, H2?
Yeah. Anushka and Ahmad, have you got the answer?
I'm doing so.
Done, but I got it a little wrong.
It's very easy, Anushka. You can see. I'm gonna write this as CH3, CH2, and then C double bond OH. This is a reducing agent which can break both bond between carbon and oxygen. For breaking one bond between carbon and oxygen, 2 hydrogen will be added, 1 to oxygen and 1 to carbon. Another bond will be broken, hydrogen and hydrogen. Now you can see this is CH3, CH2 was there, and then with the third carbon, we had CH, and you can see this hydrogen and this hydrogen, so we can write CH2, and with H2 hydrogen it's 4. Just let me know when you're done with this.
Yes, sir, done. I got it correct only.
Very good. Now the next, Ahmad, are you done with this?
Yes, sir. Done.
Now the next reaction to convert aldehyde or ketone to alkane or hydrocarbon. This is known as basically Wolff-Kishner reduction. Wolff-Kishner reduction. And also you can see again the same statement will be there, and here we are going to treat with hydrazine. So first of all, I'm going to write a point about this. This name reaction are very important. The carbonyl group of aldehydes and ketones. The carbonyl group of aldehyde and ketones is reduced to CH2 group. On treatment with hydrazine. Hydrazine is basically NH2, NH2. This is the chemical formula for hydrazine. Followed by heating with sodium or potassium hydroxide. In high boiling point, boiling solvent. In high boiling solvents such as ethylene glycol. That is known as Wolff-Kishner reaction. Again, same process, only reagent changes. So I'm going to write the reaction first and then I will explain. Just let me know when you are done with this. In this, the reagent will be hydrazine, that is NH2, NH2. Then removal of water will take place. Then it will form imine like this, and then followed by potassium hydroxide in the presence of ethylene glycol, and when we heat it, we will get this CH2 with evolution of N. And this reaction is known as Wolff-Kishner reduction. Please do write.
Sir, is that C double bond NNH2?
Yeah.
Sir, done.
Everyone done with this?
Yes, sir.
Done, sir.
Very good. Now I'm going to explain it, the mechanism, which is very easy to understand. You can see there will be removal of water, as you can see here. So I'm going to write it C double bond O, and I'm going to write this reagent as H2N NH2. Can I write this? So just remove water from here, and you can see there will be double bond between carbon and nitrogen now. So this will be the product you are formed. Now again, this is reacting with KOH in the presence of ethylene glycol, and you are going to heat it, and reduction will take place. One bond between carbon and nitrogen, then hydrogen and hydrogen, another bond, then hydrogen and hydrogen. Now you can see that the product will be like this, the main product. And you can see this and combined to form NH2. And whatever is present, like 4 hydrogen is there. So this is K plus and OH minus. So hydrogen will combine with OH to form H2O again. This is the main product, that is hydrocarbon. Please do it. And let me know if you have any. Yes,
So
sir.
this we have 4 hydrogen. How did that become CH2?
H2. See, we have 4 hydrogen, 2 hydrogen on nitrogen side and 2 hydrogen with carbon. So this is the main product, yes or no?
Yes, sir.
Now again you can see that this is again becomes NH2 NH2. So basically by heating, when you are going to heat it, there will be bond breaking between hydrogen, hydrogen, nitrogen, hydrogen, and there will be evolution of N2. Is that clear?
Yes, sir.
And now 4 hydrogen is there in the solution that will either make water, like OH minus and H plus combined to form water. So that will be in solution. Okay. So the product found here is hydrocarbon and N. That will be evolved. And this hydrogen combined with OH to form water in the solution. Everyone done with this?
No, sir, 1 minute.
Okay, take your time. I'm going to give some question at last. And in the next class, we are going to study about the oxidation. And then there are some tests like valence and tolerance. Then aldol, which is very important. Then we will start carboxylic acid. This chapter might be completed in the next week.
So when we'll finish this,
This chapter,
sir, the next one.
the next one, that means what do you mean? The next one, I didn't get you. Are you talking about this chapter?
I forgot the name. It is NH aniline something.
Amine,
Yeah, sir. Amines.
after completing this chapter, we are gonna start Amine.
Sir, when we'll finish the chapter?
Which chapter? Amine.
Yes, sir.
See, in the next week, we are gonna complete this chapter and then start Amine. Then Amine is not that much big chapter. That will be completed in the next week. Okay.
Sir, I have my chemistry half yearly exam on 18th of December, and I have aldehyde, ketones, amines, and coordination compound.
18th of December. Inshallah, we will complete before that. Okay.
Okay, sir.
Predict the products formed when cyclohexane carbaldehyde reacts with following reactions. So first you are going to react with cyclohexane carbaldehyde with pH MgBr and then hydrolysis, that is H3O positive. Is there anyone who has unit test or pre-board or anything in the next month except that? Anushka, is there any test of yours?
Sir, for us in our school, we have a mock one from 30th November.
What is the syllabus of chemistry?
Sir, we'll have both the two books for mock one.
Okay, that means complete syllabus is coming there, right?
Yes.
Okay, please do it.
Yes, sir. Could you repeat?
You're lagging.
Please do this question.
So you're not audible.
Please do this question. Am I audible? Am I audible?
Yes, sir. Now, okay.
See, I'm going to explain it. First, we need to write the structure of cyclohexane, carbaldehyde. So it will be like this. This is your cyclohexane and carbaldehyde. That means aldehyde is there. And you are going to react this with PHMgBr. So as you can see that this is aldehyde and this is did not reagent. So there will be positive, there will be negative. Again, there will be negative, there will be positive. And just make sure you are going to do the opposite charge attract each other. So you can see this is CH that will combine with PH. And then you can see that, wait a minute. With this, you can see that there is O minus, Mg plus, and B. And again, if you're going to do the hydrolysis, it's positive. So it will have two parts, OH minus and H plus. Again, opposite charges attract each other. So this positive will go to this. So what you will have as a main product is this. This is CH. There is pH. pH, that means basically benzene group, and there is OH. And as a byproduct, you will get Mg, OH, Br. Is that clear, everyone?
Sir, could you explain once again?
Yeah, Anushka, it's the same as you can see there is carbonyl compound. So what I did, there is negative charge because it is more reactive, electronegative, and there is positive charge, less electronegative. This is carbon and this is magnesium, so it will have positive, it will have negative. So between carbon and oxygen, one bond will be moved to oxygen, that's why there is negative charge. So carbon has positive, so it will go to this point, and this positive will go to this point. So you can see C and H was there, so it is H, and pH goes to this C, so it goes to this C. CO was there, negative, and oxygen with magnesium will go to O minus, so this will again H3O positive, that means H plus, and OH minus. H plus will go to O minus and form alcohol. And pH was there, so as it is CH, and then OH minus will go to this Mg, so it will form MgOH. Okay, is that MR?
Yes, I got it.
Okay, so this is it for today. I want to give some questions from NCERT. And we are going to do from 12.1 to 12.10. Apart from carboxylic acid, whatever we have studied till this, like preparation of aldehyde ketones, and then the chemical reaction of this ketone and aldehyde. There will be some questions that is not covered yet, but just leave that. Except that, try to attempt all questions. Okay, Anushka, Amar, is
This
that?
question, the exercise section or the example?
Yeah. Exercise it is.
Yes, sir.
Okay.
In text, right?
No, exercise. In text questions are different from exercise questions.